paper for your notes for this. Good call. Everybody got one? Take a look at this. This is what you will put in your notes under slope. I suppose I could try and see if I got that here so I can pull it up. Got all about not doing this. Let's see if I can find it here. Under math. Either under slope or under your class. I'm not sure which it would be. We'll try your class first. That would be the most logical. Who is that making that noise? Will you go stand outside, please?
Yes.
Can somebody tell you to stop?
I do want to be.
Yeah, I think the word shush. Did somebody say shush? Yeah, I think so. That's what I took it as. I don't think you were talking to me, were you?
No.
All right, where were we? Now I don't remember. I'm all discombobulated.
Slope of a line.
Yeah, no. Say slope. What lesson is this? I'm gonna guess it's back here somewhere. Under slope. Something that says for notes. Worksheets were a bunch of lines with slope. I don't think that's it, do you? Duh. No, not. I must have saved it somewhere. Otherwise, I'm just going to, wow, look at all that. I think it's stuck somewhere in there. P, Q, R, solving. I don't know why I wouldn't have put it under 17 sacks in here. Course 3. Slides, worksheets, lessons, teachers, baseline, quiz. See anything that says slope? Investigation, A, transversals, FOIL, trigonometry, no, it's Pythagorean theorem, puzzle. Oh! Just gotta look for slope for notes. Alright, here is the gist, boys and girls and kids of all ages. We are talking about slope, and there is a bunch of different ways to think about slope. You hear the word slope, when you talk about skiing, because, ski slopes are exactly what we're talking about. And when you talk about slope, you just have to remember there's a bunch of different ways to think about it, and this gives it one of the ways the book says is it's when you have a line, any sort of a line, it's really a comparison is what slope is. You compare the rise, which is how far up something goes, over what's called the run, which is how far over it goes. So you can tell that they have this line here and they made triangles. And with the triangle, with a right triangle, you can see, you come down here and you make a right triangle here like this. With a right triangle, it helps you see how high your line goes for every how wide it goes. Let's say this goes 3 units up. For every 4 units over, that is its slope. It goes up 3 when it goes over 4 on the bottom. That is rise over run. There's a couple different ways. They also label it as the change in y. Okay, change in y over the change in x. Which makes sense because when you want to find the distance of something, it's a subtraction problem, the difference. From here to here, you just subtract those two and you're going to get that sort of thing. It's a ratio of rise to run. So here's what you need to do. And I have that note paper there. I'm going to copy this And it's in wonderful living color so you can see the difference in the lines. Don't worry, we'll get it here. When you are asked for slope, okay, what do you need to do? And does it say on the sheet? No, it doesn't necessarily say. Here is what you need to do. Let me give you the, you need to step number 1, you need to make a right triangle with the line. Make a right triangle with the line. And this is the part that always confuses people, okay? In order to do that, ladies and gentlemen, and boys of all ages, in order to do that, let's say I'm doing the green line, you have to find 2 points on the line, okay? Which means this, you're looking at a green line, okay? You gotta find 2 coordinates that are on that line. I can't pick this point right here because you can't tell me what the coordinates of that are. This is like x 1/4, y 3/4, or some negative 3/4. So you need to find a place like this. See where the line crosses? Maybe if I make this big enough, you'll see. That green line, you can tell me where to go. It's a little off. Maybe I should make it smaller. Okay? You can tell that it crosses both an x and y coordinate. You can give me the coordinates of that line. You can tell me what that is supposed to be. Okay, I will figure it out here. Okay? So right here, no, don't do it. So right here, you can tell me that that coordinate is what? 1, -2. But you don't need to tell me that because that's not what we're doing. But that's 1 point you pick. Then you have to find another point, which, believe it or not, and it doesn't matter, it could be any of them. This is another one, 0, 0 is another one, correct? And then here is what you do with it, children. Go straight down from one point and straight across from the other point, and that makes a right triangle. See this nice little triangle that I have here? And once you have a right triangle, you can tell, remember it's up, over, or how high is the triangle. This triangle that I just colored in, how many units high is it? 1, 2. How many units over is it? Just 1. Okay. Now, you would say then the slope of that is 2, but you'd be kind of wrong. Because the other thing we have to think about is, Carter Westphal, lines can either have positive slope or negative slope. Okay? You need to jot this down. Positive slope, this just goes up really fast. Positive slope goes uphill from left to right. In other words, you would not be able to ski on a positive slope because you'd be going against the force of gravity. That positive slope is you climbing up a mountain. Okay, it is this. You are going up from left to right. Negative slope, negative slope is going down from left to right. That would be a ski hill. You would definitely be able to ski down that hill. So this one that we did here, since this green line is going downhill, you could slide down it. It is a negative . It is a negative 2. Comprehende-vous? So it's probably a good idea. The blue line, negative slope or positive slope? Positive. The red line, negative slope or positive slope? Both positive. You're climbing uphill. Uphill both of them. Let's find the slope of the red line. So again, and we'll do this, we will do this in a big way here, just so you can see it, okay? I don't want that color. Let's go this. Okay, let's say on the red line, I picked this point because it does cross there, and I picked this point because it does cross there. Remember, go across, and it doesn't matter which one. You can go across on one point and up on the other point, or I could do it. I can make my triangle this way, go across here, and go down here, which gives me this great big triangle here. Or you could have gone up with this point and across with that point and got the same triangle on the other side of it. It doesn't matter which way, but you need to make a right triangle out of it. And if this is my triangle, let's color if you can see it here. If this is my triangle, how high is my triangle? It's 1, 2, 3, 4, 5, 6, 7, 8 high. How wide is it? 1, 2, 3, 4, and yes, you do need to reduce this. 8 over 4 is 2, but this one was 2. Yes, one was 2, the other is negative 2. This one is a positive slope. So they are different slopes, one's going uphill, one's going downhill. You tell me what is the slope of the blue line? Sounds like I'm talking about trains in Chicago. The blue line slope is Jan, fair slope of blue line. First of all, you want to say it's a positive or negative. To me, it looks like it is positive. The slope of said line, Abram Savages.
I got 2.
Oh, you got to what? It's a small math joke. Brand?
I got +1.
I got +1. We have a 1 and a 2. Neither of which I believe are correct. Evelyn?
1/2 or 2 over 4.
Well, always go with your fraction
1/2.
reduced. It's 1/2. Again, people, here you go. Brant, what points did you pick? Well, here, I'm gonna run my finger on the blue line. You tell me what point you picked.
There.
Okay, I agree. It crosses right there.
In there.
All right, you picked the 2 farthest points. There are a few others you could have picked, but that's fine. Did you go up from here? So you go up from here. Did you go over from here? Made a nice right triangle. Okay. It is the up. How far up over the over? How high is this triangle? What is that distance?
4.
4. How wide is that triangle from there to there?
8.
So how did you get 1 if you have 4 over 8?
I just did the 1/2.
So you're telling me $1 is the same as a half of a dollar? They're 2 the same thing? Math don't quite work that way. 4 over 8 is 1/2 slope. Is it positive or negative? It's going uphill, so it's positive. Positive 1/2 slope. You could have very easily, children, you didn't have to use those, because if you'd have followed your finger up this line, right here's the next one. It crosses right there. You could have made the smaller triangle, in which case the height is 1 and the width is 2, which would give you the 1/2 right away. You could have gone here, in which case you'd have 2 and 4, still getting 1/2. Slope sound good? Look at page 300, well, no, does it ask you to go? Oh, yeah, look at page 304. Write this in your notes, we will do this one. Letter J on page 304 says, what is the slope of a line passing through 1, -1, 1, -1, and I'm sorry, it's not 1 negative 1, it's just 1 1 and 5 negative 1. Which means, and again, I don't have a graph. Oh, I do have a grid right here. How about this? I do have one. I was just doing one for 8th grade. Where is it? Poof. Wow. What were those 2 points again?
1 and 1 and 5.
1 1, right? So that point's right there. Let me do a blue. What was the other one?
5 and 5.
5 negative 1. So here's my line. Hello, my line. I am malaligned. Oh. Wait, I don't see any human at all. I don't know how you would possibly laugh at that. Here's my line. What, and I'm asked to find the slope of that line. And the nice thing is, you already know 2 points on the line because they gave them to you. So I would use those lines. I have this point, and I have this point. Here's my triangle. What is the slope of that? Tell me right now what the slope of that is. Up, over. Up, the UP, over. And be careful with that. Be very, very, very careful. What is the slope of that line? Wade Davis?
Negative 1/2.
It is a negative 1/2. Why? This is too high, that's how high it is. It is 4 wide, and it goes downhill, so it is negative. You reduce it, it's a negative 1/2 slope. And I don't, oh, there we go. No, yep, no, yep, no, yep. I was gonna ask you, what if you had a line that looked like this? Because you can't make a triangle out of it. Or what if you had a line that had this? And maybe we'll write this down. If you did make some sort of a triangle out of this, remember it's how far up it is over how far over it is. How far up is it? 0. And how far over it? It could be any number. But 0 divided by any number is?
0.
0. So horizontal lines have 0, or I believe it's also called no slope. That's what horizontal lines have. If you look at the vertical line there, scary as this might be, again thinking about the up over the over, how far up is it? It could be any number, but how far over is it? 0. And ladies and gentlemen, I don't know if we've come across this before. So let's just pick 15. 15 over 0 is what? Does anybody know? It's the same thing as 15 divided by 0.
Thou shalt not divide by 0.
You cannot do that nor have that. This is what in math we call undefined slope. You can't do this. That's a huge math no-no. Why can't you? Does anybody know? Since we got a little time, let me look at that here. Let me do an easy problem. If you have 4 over 2, what does that equal?
2.
2, correct? Which means division is nothing more than backwards multiplication, correct? You could look at this and go, okay, 2 times 2 is what gives me 4, correct? Yes? Well, if I have 15 over 0 and I want to know what that is, you have to tell me what number when I multiply 0 by it gives me 15. 0 times what number is 15?
Can't do it.
You can't do it, there's no such thing. Hence the reason why You shall not, nor can you ever divide by 0. Oh,